In this video, we are going to explore a new sorting algorithm, Heap Sort. First, we will be looking at the working of Heap Sort, then we look at its code, then we will talk about the complexity, advantages and disadvantages of Heap Sort. So, without any further ado, let's jump straight into it. Before we begin, the prerequisite of this video is that you should be comfortable working with Heap. Heap Sort utilizes Heap for sorting, so you should know how to implement Heap, the Heapify, insert, delete and extract min operation. If you don't know what I am talking about, then I highly recommend you to explore Heap. I have linked a video on Heap on the cards and in the description. Check it out and you will be set. Heap Sort is a comparison-based sorting algorithm based on binary heap data structure. It is similar to selection sort, where we find the minimum element and place the minimum element at the beginning and repeat the same process. So let's understand the working of Heap Sort in depth with an example. We have an array of 8 elements 6, 4, 2, 10, 22, 0, 3 and 1. We apply Heap Sort to the array. Heap Sort first creates a min-heap from the elements in the array by calling Heapify operation. Then Heap Sort repeatedly calls the extract min operation of the min-heap and updates the array with the elements returned by the min-heap. Let's apply this principle to our example. The Heap Sort applies Heapify operation, which creates a heap where 0 is our root node. Its children are 1 and 2. 1's children is 6 and 22, 2's children is 4 and 3 and 6th child is 10. Note that minimum element of the heap is at the root node. Heap Sort utilizes this feature of min-heap to sort the array. Let's look at how does it do it. At the first extract min call by Heap Sort, heap returns the minimum element, the root node, or as per the example, we get 0 in return. 0 is then added to our previous array. Note that after the extraction of 0, 1 is our new minimum element in the heap. Now you might be asking, how does the heap always bring up the minimum element to its root node? So I had recommended you to explore heap. Here we only care about the working of heap. We don't care how heap is doing its thing. With that out, again Heap Sort calls extract min. Heap returns 1. 1 is added to the array. This process is repeated until all the elements in the heap has been extracted. Finally, we have our sorted array. Now, with that in mind, let's look at the steps we took to sort the array. First, we convert our heap into a min-heap structure by using Heapify operation. Then, we repeatedly call extract min operation, which returns the minimum element in the heap. We then append the returned element to our array. This process is repeated until the heap is empty. This is how Heap Sort works, and if you know the working of heap, then it is very simple. So, I request you to please explore the heap if you do not understand. Now, let's look at the code. We have already implemented the min-heap data structure in our file. Our min-heap can store up to 20 elements in the heap. Here I have declared all the functions required for min-heap data structure to work. If you don't know what these functions are, I highly recommend you to watch the video in the description. In the main function, we have an array to work with. N contains the size of the array. First we print the array before sorting. Then we apply Heap Sort. After applying the Heap Sort, the array would be sorted. Then we print the sorted array. Let's look at Heap Sort. Heap Sort takes two arguments, array and the size of the array. First, Heap Sort creates a min-heap structure called heap. Then Heapify is called on the min-heap structure. Heapify just creates a heap data structure of all our elements in the array. Then we run a for loop which runs from 0 to n, that is on all the elements in the array. The elements of the array is updated by the extract min function from the heap. As I already said, extract min function retrieves back the minimum element from the heap. That minimum element is replaced from the heap or it is deleted from the heap. As always, the source code is in the description. The time complexity of Heap Sort is big O of n log n. Now, why to use Heap Sort? Heap Sort has a time complexity of big O of n log n in all cases. This makes it efficient for sorting large data sets. Memory usage can be minimal because apart from what is necessary to hold the initial list of items to be sorted, it needs no additional memory space to work. It is simpler to understand than other equally efficient sorting algorithms because it does not use advanced computer science concepts such as recursion. Some cons of Heap Sort is that Heap Sort is unstable. It might rearrange the relative order. Heap sort is not very efficient when working with highly complex data. Now I have a challenge for you. Before looking at the challenge, if you find any value in this video, hit that like button. For more videos on DSA, hit that subscribe button. Now I dare you to sort the array in terms of descending order. You can use max heap instead of min heap to do so, or you can use some for loops to invert the array. It's your choice. If you were successful, then comment down what method did you use to solve this there. Finally, congratulations and signing out.